Hey, what's up, guys? How are you? This is part two of this problem. I just want to say a couple things before I move on. First of all, if you haven't watched part one, I highly recommend watching that because we're going to be using the answer. I should have hid that, but we're going to be using the answer of A to answer the next question. And on top of that, it'll kind of lay down some foundation for what exactly we're doing for part B. On top of that, I want to apologize for being so quiet today or right now. My neighbor's asleep and his room is right next to mine, and I know he's a teacher, so I kind of want to be respectful because of that. And yeah, so what we're going to do is we're going to copy down a couple of pieces of information, and then we can move on. That's gonna be a couple pieces. My fault. Sorry. Okay, so first of all, we know that P equals 3 1/9, and then we know R equals 4.50. We know that 3 is equivalent to W, and we know that 4.5 is equivalent to K. So now, what this question is asking you is, what is the relationship between our point W, our point's x value, and the x-intercept of the tangent for all of W that's more than 0. Find K in terms of W. So what we know already is that W equals 3 and K is 4.5. Something that's very easy to do is we can just set these equal to each other. 3x equals 4.5. We know that we can just divide 3 actually. Divide 3, x equals 4.5 divided by 3, which is equivalent to 3/2. This is a really bad example of a fraction or whatever, or a fraction, because you would never actually do this. If you were to actually do something like this, you would probably set this to equal, I would say, 9/2. So 3x equals 9/2. If we divide by 3, then we're going to have x equals 3/2. So right now we have our relationship. That was extremely easy. We have our rule. My fault, sorry, this is like bad handwriting. X equals 3/2. So we have that. But I know what you're thinking. Okay, that was too easy. Maybe that answer is wrong. Because, sometimes things that are too easy might be wrong. So I'm going to provide an example that you don't actually need to do when you're answering on a test. At least I wouldn't do this on a test. Actually, maybe I would if I had time, but don't do this first if you are answering a test. So we have this, we have our answer. What happens if I plug in a different number? What if I say W equals 1? So we know that P, the rule for P is W and then 1/W squared, correct? So let me plug in 1. So P will then equal 1, 1, which is a really nice and easy number to play with. Now, what I'm going to do is I'm going to do the same exact thing I did in the last problem. So f of x equals 1/W squared. I'm then going to, or 1/x squared, my fault. We know that this is x -2, blah, blah, blah. We're going to do f prime of x equals -2/x⁻3. We got this in the last problem, which is why I'm not really going over it. So then we're just going to plug in 1 again, or we're going to plug in the x to be whatever our x value was. So in this case, in the first case, we plugged in 3. Now we're going to plug in 1 because we want to find the instantaneous rate of change at x equals 1. So we plug in 1. We're going to do -2/1. We know that now this has a slope of -2. Perfect. Actually, I shouldn't have circled that because that's good information, but it's not the answer of anything. So once again, we know Taylor's form is saying y equals mx minus x1 plus y1. And we know that we can just plug these in. 1, 1, and then -2 right here. Y equals -2 x minus 1 plus 1. All right. Now we just set y to 0. Just like last time, we're finding the 0 of the tangent. -2 x minus 1 plus 1. I'm going to subtract 1 from both sides, -1. So now we have -1 equals -2 x minus 1. Divide by -2. We're going to get -1 divided by -2 is going to be 1 over 2 because the negatives cancel each other out, equals x minus 1. We add 1 to both sides, plus 1. 3 over 2 equals x. Now, we have our point R for this situation. R is 3 over 2, 0. Now, the relationship between 1 and 3 over 2 is 3 over 2. So, if we were to set these equal just like these, we would say 1x equals 3 over 2, and we know that x would have to be 3 over 2. So there you go. That was just 2 different points on this same line, and we were able to tell that the difference, or the relationship between the tangent 0 and the actual point, the tangent x value at, or the tangent 0 x value, and this point value is 3.5. All right. I'll see you guys later. Bye.